Further ado, let's get started. Multiple representations. Practice representing linear relationships in multiple ways using the following examples. Use the representation given to help you fill in the others. So let's go over some of these and see what multiple representations has to say about graphs and linear equations. A baby giraffe measures 6 feet tall when it is born and grows an average of a half foot each month. What is the relationship between x, the number of months, and y, the height of the giraffe? So remember, in our equation, we have y equals mx plus b. This is what we always start with. So your b value is going to be where the graph starts at 0, or where x equals 0, or in this case, where the month when the baby giraffe is born, so month 0 when it's first born. And it says that it's 6 feet tall when it is first born. So that b value is going to be 6 in this case. Then we have to figure out how much it is growing each and every month. We do this by looking at the m value, our slope. It says it grows a half foot each month. So at month 1, it's going to be 6.5. Month 2, it's going to be 7. Month 3, it's going to be 7.5. And we can represent this by the equation y equals 1/2 x plus 6. Let's look at the table now. So, process. Oh, okay, that's what it means. So when it says process, I'm pretty sure that's referring to the equation and what you plug in for x. So if the equation is y equals 1/2 x plus 6, the process would be y equals 1/2 times 0, because 0 is the months, plus 6. And so my height in this case would be 6. Let's go fill in a few others and you guys can do the rest. So y equals 1/2. And instead of 0 this time, we're going to plug in 1 because that's the number of months that have passed. So 1 times 1/2 is just a half. A half plus 6 is 6.5. So I would write 6 and 1/2. Go ahead and fill in the others until you get to 6, and then you can join me over at the graph. Now this graph says it's going to start at 6, and it's going to go up 1 and over 2, because it wants to grow half every month. So if I draw that out, the graph is going to look like this, and it's going to go, if we zoom in and take a look at it, it's going to go up 1 and over 2, up 1 and over 2, up 1 and over 2, each and every time. And then you can trace how tall the giraffe's getting after so many months. So we can say at 8 months, the giraffe's going to be 10 feet tall. All right, use representations in example above to answers 1 through 5. So let's look at this really quick, and then we can go on to the next one. So explain how you found ordered pairs to create your graph. Well, how did we find our ordered pairs to create the graph? Well, I did plug in an I decided on a month value, and I figured out the height. Based on the month. So pretty easy stuff. So basically you decide what x is, and then based off your x, you figure out a y. What is the slope of the graph and what does it represent? The slope, hopefully you know the slope is 1/2 in this case. And it represents the height of the giraffe is growing each month. What is the y-intercept of the graph and what does it represent? Well, if you look back to the question, you can see that the y-intercept is 6 and it's represented of the giraffe when it's born. So we're just going to say that. It is 6 and it's the giraffe's height when born. What does the ordered pair 9 and 10.5 represent in the context of this situation? Well, think about it. 9 represents the months, and 10.5 represents the height in feet. So what does it represent? In 9 months, the giraffe's height is 10.5. So you can break these problems down into their simplest form. It does not have to be confusing. All you have to do is read, understand what it's telling you, and then make an equation out of it. If the giraffe is 12 feet tall, how many months old is it? Well, think about it. It grows a 1/2 foot every single month. And so if it's growing 1/2 a foot, it must take 2 months to grow 1 foot, right? And so how many months would it take to grow another 6 feet because it was initially 6 feet tall? Well, 12 months. So I'm going to say the giraffe is 12 months old or 1 year. All right, we're going to go to the next page. I'm going to do, let's see. I'm going to do the next page with you. And then you guys are going to do the next 2 pages by yourself. All right, so, sorry, that's the wrong one. Here we go. Use the information given for each situation below to fill in the missing representations. So it looks like the equation is 12 plus 1.5x. Okay. The table looks like it has a pizza on it, and it says toppings, process, and cost. And then if I look at the graph, it says the cost and number of toppings. So I'm going to use these context clues informations to write myself some background information. So I'm going to say a pizza costs $12, and it looks like it starts at 12 and costs $1.50 per topping. So I'm going to say, and $1.50 per topping added. And that's my verbal description. Pizza costs $12 and $1.50 per topping added. Easy as that. Doesn't have to get more complicated than that. And then you can see $12 is where it starts. 1.5 is how many toppings you have. The process is going to be y equals just like the last one. $12 plus 1.5 times 0, because that's with 0 extra toppings. And then the cost, well, if we calculate that out, 12.5 or 12 plus 1.5 times 0 is just 12. Easy peasy there. If you do 1, it's going to be very, very similar. It's going to be y equals 12.5. 12 plus 1.5, 1.5, there we go, times 1. And then you can guess the cost from here, but you're just going to add 1.5 and 12, and it's going to be 13.5. And really, it's nothing complicated here. All you're doing is just multiplying and adding on the extra cost. I mean, this is how most restaurants figure out like their toppings per pizza anyway, so. And then our graphical representation, well, if we're starting at 12 and we go to 15, that's going to be 2 toppings. And so my graph is going to look something like this. There we go. So if we represent 1.5 as a fraction, it's 3 over 2. You can see we're going 3 up and 2 over. 3 up, 2 over, 3 up, 2 over. Also, keep in mind, if a graph counts by 3, you have to think about it like that. All right, last one, and then you guys can do the rest as of this as homework. So fill out the notes and then do the assignment that's followed by this as homework. All right, this video is running a little long, so I'm going to end it here. Good luck in figuring out the rest of these. And if you need more help, you can rewatch the video or ask me in class. Thank you so much for watching. This has been Mr. Hawkins.